We already know how computers can receive an input from a range of devices, such as a mouse, a keyboard, or a touchscreen, and that these are all different ways in which users can interact with computer programs. When computer programs run, they will often be seen to run on a monitor. This is known as an output device. An output device is any piece of hardware that a computer program can control. Often this is done to provide information or feedback to a user, such as through a screen, a printer, or a pair of speakers. However, sometimes the sole purpose of a computer program is to control the hardware. That's why the program was coded. For example, a computer program might be coded to turn a heater on or off, or to change the brightness of a bulb, or even to open a garage door when a car approaches. In each case, the computer program will do the thinking. It will decide whether to activate the heater, turn the bulb on or off, or operate the motor. The output device will simply do as it's instructed by the computer. Most computers offer very simple connections to output devices. They might only include a connection to a monitor or a pair of speakers. To operate other hardware, such as bulbs, buzzers or motors, an input-output controller, often known as an I/O controller, may be required. These can be added to desktop computers, but the simplest thing to do is to use a computer that has this built in, such as the Raspberry Pi or the Crumble from Redfern Electronics. Let's take a look at the Crumble computer. This, would you believe it, is a tiny computer. This is the processor, which is effectively the brains of the computer, and dotted along here are the other components that help to make it work. To power it, we connect 3 AA batteries to the positive and negative terminals here. So what do the other terminals do? Well, they allow us to connect external components that we can then control from our programs. For example, we could connect an LED and make it turn on or turn off, or connect a motor and speed it up or slow it down. We can even connect buttons and sensors as input devices, which we can then use to trigger things to make them happen in our programs. Working with external hardware opens up huge opportunities for bridging the gap between virtual computing, which is stuck inside a computer, and the real world, which is all around us. It gives us opportunities to control the things around us, perhaps making our lives easier or safer. It even means we can control the way a program runs without having to be sat in front of a computer, using just a mouse or a keyboard. This opens up lots of exciting programming opportunities.